But before we get into all that, let's go through some of the history of relativism, especially within Western intellectual tradition, Western culture. So let's rewind the clock 2,500 years and go back all the way to the ancient Greeks, to the ancient Greek philosopher known as Anaximander, whose dates were 610 to 546 BC. He was one of the very, very, very earliest philosophers in the West. Really, you could say philosophy sort of began with him and his contemporaries. And he resolved a very interesting philosophical and, at that time, scientific problem. Because remember, back then, philosophy and science were the same field. There was no distinction between them. So, what was the problem that he resolved? Well, it was the problem of the floating earth. Contrary to what some people think, the ancient Greeks actually knew that the earth was a globe, that it was round. And for them, though, the tricky question wasn't whether the earth was round or flat. They understood that it was round. What puzzled them was, how could a round earth sit suspended in empty space? Almost all ancient cultures assumed that the earth rested on some support, that it couldn't just float in empty space. Because the assumption was that if it was sitting in empty space, it would fall down. And of course, the earth isn't falling down because we don't feel it falling down. So that means it must be supported by something. This was the way people thought back then. Now look, what you have to understand is that this might seem silly to you that people thought this way, but you have to really put yourself in their shoes and really look at it from their epistemic perspective, from their sort of veil of ignorance. They didn't have the benefit of standing on the shoulders of giants and visionaries and great scientists and philosophers that we have today. You know, we have 2,500 years of hindsight and standing on the shoulders of giants. So this was a real puzzle back then in Anaximander's time, and he came up with the solution for it. And here was his argument. Here was his great, brilliant insight. This was an insight equivalent to Newton's insight about the apple falling and being pulled down by gravity. This was an insight equivalent to Einstein's insight about the nature of light and space and time. And his insight was very simple. He said the following: the earth can sit unsupported in an empty void because it is falling and it is pulled equally in all directions. And the only way he could have come up with that line of reasoning is by realizing that up and down are actually relative. So something as simple as up and down being relative, which we all understand today, at least I hope so, this was not obvious at all to early humans. Because our direct experience is that there is an up and there is a down. And all our lives we live within this field, this polarized field of up and down. And it just seems that objects just intrinsically fall down. And staying up is inherently difficult. And up is always that way, and down is always this way. And no matter where you are on the earth, that's true for you. But then, of course, if you think about it a little bit deeper, you realize that, well, wait a minute. If I'm on the North Pole and up is this way and down is that way, and then if I'm on the South Pole, it has to be reversed. See? Relativity. That's the only way the earth could be round, is if that relativity was true. You could see how a lot of people could refuse to accept that the earth is round simply on the grounds that means that up and down are relative. And their direct experience clearly shows them, and they have decades of this experience because, most people have not flown to different poles of the earth. Especially back then, there was no such possibility. So your direct experience was simply that up is that way and down is this way, and it can't be otherwise. You see, the mind was locked into that paradigm. And Anaximander's great insight was that, in a sense, Earth is falling, but it's falling in all directions at once. Therefore, it's sitting still. See how it kind of goes full circle? A very clever bit of thinking. And of course, that's exactly how it is. And now for us, it's easy to accept this because we have watched a bunch of science fiction movies, and we know we've had astronauts in space. We've seen footage of them floating around. And true enough, if you have a droplet of water in outer space, it just hovers like in this very eerie way. It has nowhere to go. Where can it go? See? And that's very counterintuitive to us, and it's kind of spooky and eerie. Like if I just snapped my fingers and you found yourself right now floating in the vacuum of outer space on the International Space Station, you would be really creeped out by that because it would be so different than what you've been used to your entire life. And yet, actually, that is the more true, more general way of looking at reality. Not this way that we live on the planet, because this is a very local portion of the universe which has an up and a down, but most of the universe does not have an up and a down. You see, so up and down are only relative to this context of being on this planet. So that's Anaximander, one of the earliest examples of relativity. And really, what I want to show you here is that mankind's greatest developments, scientifically, philosophically, and culturally over the last 2,000 years have often been discoveries, huge landmark discoveries of relativity. And each time one of these discoveries was made, it was made by some genius, brilliant visionary thinker, and then it was opposed by the majority of people who were not visionary genius thinkers. And then what happened is that after many centuries of debate and controversy and rejection, finally people came around and accepted the truth of relativity. So here's another example is with Copernicus. This is exactly what happened with Copernicus when he proposed that the Earth is not at the center of the universe. This was a brilliant bit of relativistic thinking, because at that point, the religious dogma and orthodoxy simply said that the planet must be at the center of the universe, and everything else revolves around the planet. Of course, this is a very self-centered, literally self-centered way of looking at the universe, and of course, that's part of the problem, is that every time that we're looking and making sense of the universe is that we're looking at it very self-centeredly. And so we have to kind of step outside of our own selfish agenda and selfish perspective to see how it really is. And so, of course, Copernicus proposed this idea that the sun was really more central than the Earth. And then later we found out that even the sun is not really the center of the universe, but just one out of millions of other suns that exist. And so that really dislocated us from taking any kind of central position within the universe. And this was opposed by the church, by the orthodoxy, even by many scientists at the time, because it certainly doesn't feel to us in our direct experience that the Earth is moving. See? It seems like everything else is moving. It seems like the stars are moving, planets around us are moving, the sun is moving, but the Earth is not moving. It's stationary from our point of view. But of course, if you went and stood on the moon, for example, it would feel the opposite. You would see the Earth rotating around. You would not see the moon rotating. To you, the moon would feel like it's at the center of the universe. You see? And that's the essence of relativity, is that it's very difficult to notice the relativity because you're enmeshed in the very thing that you're investigating. It's precisely because you're standing on the Earth that it's difficult for you to realize that the Earth is moving. See? It's precisely because you take a stance within your moral framework, whatever it is, that is difficult for you to see that your moral framework is relative.